Hello everyone, I'm Dr. Godandaraman. In this section we are going to discuss with MCQ unit 2 two-dimensional random variable. See the problem. From the following joint distribution table given the value of k to calculate. So how to calculate the value of the k? Here every values are discrete. Joint probability mass function is nothing but summation of x comma y equal to 1. So y range given 1 to 3, x range 0 to 2 given. But very simple to calculation. Total probability value 1. Just add these values. See 5, 3, 1, 9 k, and then 10, 12 k, then 15 k. So the total 36k equal to 1, k equal to 1 by 36. See, this option is nothing but D, 1 by 36. And then this problem table is not given, but to frame the table x, y. Now to consider here x, here y. So y values 1, 2, 3. X value 0, 1. So when I substituted x 0 for here, where for here x is 0, then y 1, 0 plus 1. 0 plus 1 is 1, therefore it's a k. 0 plus 2, 2k. 0 plus 3, 3k. Then 1 plus 1, 2k. 1 plus 2, 3k. 1 plus 3, 4k. Now the joint probability mass function summation p of x comma y 1, the y 1 to 3, x 0 to 1. The total probability 6k, and this is a 9k. So 15k equal to 1, k equal to 1 by 15. Now the option k 1 by 15, option A. Now next problem. If x and y have joint probability density function f of x comma y k into x plus y, the range x 0 to 1, y range 0 to 1, then the value of k. When joint probability density function is nothing but integral over f of x comma y. So here to calculate k, the double integration f of x comma y dx dy equal to 1. The y range, x range, minus infinity to plus infinity, minus infinity to plus infinity. Now substitute f of x comma y value and then x range, k x plus y dx dy equal to 1. So x range 0 to 1, y range 0 to 1. Now first integration with respect to x, taking k common, constant, y 0 to 1. Now x integration, x square by 2 plus y into dx, y constant, dx integration x 0 to 1. Now dy equal to 1. Substitute upper limit, where in x variable substitute upper limit. When I substituted 1, 1 by 2 plus x1 means y, upper limit minus of lower limits, dy equal to 1. Therefore now k y 0 to 1, 1 by 2 plus y dy equal to 1. 1 by 2 into dy, y by 2, y into dy, y square by 2, 0 to 1. So upper limit 1 by 2, 1 by 2, lower limit 0. Therefore 1 by 2 plus 1 by 2, 1, k equal to 1. The option is B, 1. And next problem, f of x comma y, if x and y have joint probability density function, f of x comma y k x y, x 0 to 1, y 0 to 1, find the value of k. Therefore double integration of kxy dx dy equal to 1, the x range 0 to 1, y range 0 to 1. Now taking k constant out, first integration with respect to x. Therefore k y 0 to 1 and then x integration x square by 2, 0 to 1, y dy equal to 1. Therefore upper limit 1 by 2 minus 0, y dy equal to 1. Now 1 by 2 when I am taking out, k by 2 y dy equal to 1. Now when I am integration, k by 2 y dy is y square by 2, 0 to 1. Upper limit 1 by 2, lower limit 0. Therefore k by 4 equal to 1, k equal to 4. Now the option 4C. And next problem, if x and y have joint probability density function f of x comma y equal to x plus y, x range 0 to 1, y range 0 to 1, then the marginal density function of x. Therefore double integration x plus y. Now marginal means f of y to calculate. F of y equal to integration of f of x comma y derivative with respect to integration with respect to y, minus infinity to plus infinity. Now y range 0 to 1, f of xy x plus y into dy. Now when I am integrating dy, x constant xy plus y square by 2, 0 to 1. Where to substitute? Y. Therefore when I am substituting x plus 1 by 2, therefore 2x plus 1 by 2, the range 0 to 1, this is a marginal function x. The option is 2x plus 1 by 2, option B. Then marginal density function y, to calculate f of y. F of y means dx integration of 2y dx, x limit 0 to 2. When I am integration 2y constant dx integration x, then 0 to 2. When I substitute upper limit 2, lower limit 0. So 4y is the marginal density function of y. The option is C. And then if x and y are independent random variable with the density function f of x and f of y respectively, then the joint probability density function of f of x comma y is nothing but, so when is a independent, x comma y equal to f of x, f of y. See, this is option C. Now if f of x e power minus x, x greater than or equal to 0, and f of y e power minus y, y greater than or equal to 0, where x and y are independent random variable, then the joint probability density function of x comma y is nothing but f of x comma y equal to f of x, f of y. So f of x value e power minus x, f of y e power minus y. Therefore now the power should add x plus y. This option is D. Then next question, the conditional probability density function of x given y. So x given y is nothing but f of x given y equal to f of x comma y, f of y. This is the x given y. Now the option is D. The conditional density for probability density function y given x means y given x, f of y given x equal to f of x comma y by f of x. Option C. Now coefficient of correlation lies between the limits minus 1 to 1. The range is minus 1 to 1. Next question, if increase in one result in a corresponding increases in the other correlation is positive correlation. If increase in one result in a corresponding decreases in the other correlation is negative, B. Now the formula for the correlation, Pearson coefficient of correlation between x and y is nothing but correlation covariance of x comma y by sigma x sigma y, option B. R of x comma y, covariance of x comma y, sigma x sigma y. If x and y are independent random variable, then the covariance of x comma y is equal to 0. If x has mean 4 and variance 9, while y has mean -2 and variance 5, and the two are independent, then expectation of xy square. Now when it's independent, expectation of xy square is nothing but expectation of x, expectation of y square. Now given, what is given? The mean expectation of x 4, variance of x 9 given, then expectation of y -2, variance of y 5. So this is a given. Now to calculate expectation of y square. How to calculate expectation of y square? Now expectation of variance of y equal to expectation of y square minus expectation of y whole square. Now expectation of y square value is not given, but variance value given 5, expectation of y square minus expectation of y -2 whole square. Therefore from this expectation of y square equal to the 4 when I am taking left hand side 9. Therefore expectation of x 4 into 9 36, the option B. So this answer is wrong. So B 36. If x and y are independent random variable with the mean 12 and 3, then the value of expectation of 3x minus 2y is, now the property expectation of ax minus by equal to a into expectation of x minus b into expectation of y. Therefore here the question is expectation of 3x minus 2y, 3 into expectation of x minus 2 into expectation of y. Now given x and y are independent random variable with the mean values given. Expectation of x 12, expectation of y 3. Now substitute here 3 into 12 minus 2 into 3. So 3 into 12, this is a 3 into 12, 36 minus 6. So the answer is 30. The 30 option B. If x and y are two independent random variable, a and b are constant, then variance of ax plus by. So variance of ax plus by is nothing but a square variance of x plus b square variance of y. The option is A. And next, variance of, if x and y are independent random variable with variance 8 and 5, then the variance of 3x plus 4y. Now variance of ax plus by is nothing but a square by equal to a square variance of x, b square variance of y. For here variance of 3x plus 4y equal to 3 square variance of x, 4 square variance of y. So 9 into variance of x plus 16 into variance of y. So the variance of x given variance of x 8, variance of y 5. So when I'm substituting 9 into 8 plus 6 into 5. 6 into 5. So 6 into 5, the value is nothing but, see, 9 into 8, 72 plus 16 into 5, 80. This is a 152. The option C, 152. If x and y are uncorrelated, then the correlation. So when uncorrelated, covariance of x comma y 0. So the correlation formula, covariance of x comma y by sigma x sigma y. When the covariance 0, then the correlation 0. The correlation coefficient of two random variable x and y is 1 by 4. Now correlation, covariance of x comma y by sigma x sigma y. Now here variance given. So what is given? R 1 by 4 given, variance of x 3 given, variance of y 5 given. Now sigma x is nothing but root of variance of x root 3. Sigma y, root of variance of y root 5. Therefore covariance of x comma y is nothing but, the question is find the covariance. So covariance of x comma y equal to R into sigma x into sigma y. So R value 1 by 4 into sigma x root 3, sigma y root 5. So root 15 by 4. So root 15 by 4 is nothing but, see, root 15. So root 15 is the value of 3.873. So 3.873 divided by 4. 3.873 divided by 4 is nothing but 0.9683. Now the option is D, 0.968. When 3 or more variables are studied, it is a problem of partial correlation. So option C, partial. Now see, this is a Jacobian. What is a Jacobian? J of x comma y by uv. So Jacobian is nothing but the formula dou x by dou u, dou x by dou v, dou y by dou u, dou y by dou v. Therefore from this x value given, so x equal to uv, x equal to uv and y equal to u into 1 minus u. So dou x by dou u v, dou x by dou v u, and dou y by dou u 1 minus v, dou y by dou v u into, this is a minus 1, so minus u. This value substitute in this form. So dou x by dou u v u 1 minus v minus u. When you multiply this, minus uv minus u into 1 minus v. So minus uv minus u plus uv. When I'm cancel this two, now the answer is minus u. The minus u option B. Now the transformation formula is nothing but f of uv equal to Jacobian of f of x comma y. So in the transformation two-dimensional random variable x comma y to uv, we have f of x comma y is nothing but, so f of x comma y equal to f of uv by the Jacobian. The option is C. Thank you.